In this module, I'll show how the VPM approach can help us understand the pharmacology of drugs used to treat depression. Let's start with imipramine, the first so-called tricyclic antidepressant. The name tricyclic derives from the chemical structure of imipramine, but this conveys no useful clinical information, which is one of the reasons why we've developed VPM to make sense of what drugs do. The lines to the transporter zone show that both serotonin and noradrenaline transporters are targeted and blocked by imipramine. Because this is a heavy line, these actions are critical to the therapeutic response to imipramine. And also because both neurotransmitter symbols are filled, we know that imipramine blocks both the serotonin and the noradrenaline reuptake sites. Note that the serotonin symbol is above the noradrenaline symbol, and this means that imipramine has higher affinity for the serotonin transporter than for the noradrenaline one. The only other relevant activity of imipramine is with the histamine H1 receptor, where the filled circle tells us that imipramine is an antagonist. But the dotted line tells us this is not seen as necessary to the therapeutic effect, i.e. this blockade of histamine receptors is an unwanted action that leads to adverse effects such as sedation. The possibility that the antidepressant effects of drugs such as imipramine, which we have just seen, and phenelzine, which we'll talk about shortly, might require an increase in serotonin, led to the development of the selective serotonin reuptake inhibitors, one example of which is citalopram. As with imipramine, we have a dark blue circle around the drug name, and that tells us that citalopram is a reuptake blocker. The solid line to the symbol for serotonin tells us that this is the therapeutic target of citalopram, and because the serotonin transporter symbol is filled, that tells us that citalopram is a blocker of the serotonin uptake site. The lack of any other lines tells us that there are no other clinically relevant interactions, and that is why drugs like citalopram were called selective serotonin reuptake inhibitors. Because imipramine was also a noradrenaline as well as a serotonin transporter blocker, attempts were made to explore if selective noradrenaline transporter blockers would also produce antidepressant effects. The best example of this class of drug is reboxetine, shown here. As with imipramine, we see a dark blue circle around the drug name, and that tells us that reboxetine targets reuptake sites. The solid line just connects with the noradrenaline transporter in blue, and you can see that the symbol is filled, so reboxetine is a noradrenaline reuptake blocker. There are no interactions with any of the other targets, and that tells us that reboxetine is selective for noradrenaline reuptake. Here we look at venlafaxine. As with imipramine, we see the dark blue circle around the drug name that tells us that venlafaxine targets reuptake sites. But different from citalopram, venlafaxine has two clinically relevant targets, the serotonin and the noradrenaline transporters. The solid symbols tell us that venlafaxine blocks both of these reuptake sites, but it has higher affinity for the serotonin one as this is above the noradrenaline one. The lack of any other interactions tells us that these are the only clinically relevant mechanisms of action of venlafaxine. On this diagram, we find a different kind of drug for depression, bupropion. The dark blue circle tells us it's a transporter-targeted drug, but its main clinical action is mediated through the reuptake blockade of the dopamine transporter. But it also acts to release both dopamine and noradrenaline. Together, these actions explain both the antidepressant effect of bupropion and also why it is effective in smoking cessation, where nicotine withdrawal tends to lead to a deficit of dopamine, which bupropion can restore. Here's an example of one of the other early antidepressants, the monoamine oxidase inhibitor phenelzine. The pink circle around the name tells us it's an enzyme-targeted drug. The solid lines show the enzyme inhibition actions are clinically relevant, and both monoamine oxidase A and B are blocked. So this is a non-selective monoamine oxidase inhibitor. The multiple colors in the symbols for the enzymes show that blocking these enzymes leads to increases in serotonin, noradrenaline, and dopamine. This diagram shows mirtazapine, which is a very different sort of antidepressant drug. It's one that works solely on receptors. Hence, the circle around the name is red. The main clinical action is mediated through the blockade of noradrenaline alpha 2 receptors and serotonin 5-HT2 receptors. These are the dark lines. The alpha 2 receptor blockade works largely on the presynaptic inhibitory receptors to disinhibit noradrenaline neurons, so increasing noradrenaline in the synaptic cleft. Similar to amitriptyline, which we will look at shortly, the serotonin 5-HT2 blockade adds to this therapeutic action. The other receptor blocking actions of mirtazapine, particularly those of the histamine H1 receptor, are shown with dotted lines because these add to the adverse effects, such as sedation and weight gain. Now here, we see one of the first follow-ups to imipramine, amitriptyline. This was one of the most popular drugs for depression of all time and is still widely used in the UK today for a range of psychosomatic disorders. The yellow circle around this drug name tells us that amitriptyline is a multimodal drug, i.e. it has actions at more than one of those 4 targets. The main action, the solid line, is through the inhibition of both serotonin and noradrenaline transporters. But amitriptyline is rather different from imipramine because it has more receptor interactions. And some of these, particularly the serotonin 5-HT2A receptor antagonism, is considered clinically relevant. Other receptor interactions of amitriptyline are not clinically relevant and contribute to the very high adverse effect burden of this medicine. For example, the cholinergic blockade of M1 and M4 receptors leads to constipation, a dry mouth, and toxicity and overdose. The histamine H1 blockade leads to sedation and weight gain. And the noradrenaline alpha 1 blockade can result in low blood pressure. This diagram shows vortioxetine, the most recent addition to the range of drugs for depression. Unlike the other multimodal drugs that were discovered by accident, vortioxetine was designed to be multimodal. The theory was that by adding relevant receptor interactions to a serotonin reuptake blocker, improved efficacy and/or tolerability could be obtained. And this has been proven to be correct. The 5-HT3 blocking actions of vortioxetine help reduce the incidence of nausea, and the 5-HT1A agonist activity reduced sexual dysfunction. It also turned out that vortioxetine is particularly good at reversing the cognitive deficits in depression, and this is thought to be due to the 5-HT3 blockade augmenting the effects of serotonin reuptake blockade on cortical glutamate function. In the next module, we shall see how similar pharmacological principles can help explain the actions and adverse effects of drugs for psychosis.